Small things like study lamp to big things like a plane require electricity to operate. Human civilization become very modern and electricity is needed anywhere from lighting, heating, cooling, refrigeration to entertainment, healthcare, engineering, transportation, communication, indoors or outdoors, all around, everywhere. Electricity generation was discovered during 1820s to early 1830s by a British scientist, Michael Faraday. Thomas Edison built the first power plant, and in 1882, his Pearl Street power station provided electricity to 85 buildings. The first street in the world to be lit by electrical bulbs was Mosley Street in the United States in 1879. Do you know electricity travels at the speed of light 300,000 kilometers per second? A spark of static electricity can measure up to 3000 volts. Above all, there are, on an average, more than 15 deaths every day due to electrical incidents in the construction industry. Our today's HSC tutorial topic is electrical safety. And you are watching Safety First. If you are new on this channel, kindly subscribe, like, and share. What I'm going to discuss today, what is electricity? What are the hazards of electricity? What are the effects of electrical shock on human body? Safe work procedures and practices to work safely while working on electrical installations. Let us jump on the topic. What is electricity? Electricity is a form of energy associated with the flow of charged particles or electrons from one point to another through a conductor, usually a metal wire. There must be an unbroken path between the 2 points through which the particles can travel, the complete path being known as the circuit. A switch can be used to complete or break the circuit, thus controlling whether the electricity flows through it or not. This is the simpler definition of electricity. Let us discuss basic terms in the electricity. What is voltage? Power flows along a conductor where there is a difference in electrical pressure between the two terminals. This pressure difference provides the push to move the electrons and is measured in volts. Symbol is V. What is current? This is the flow or the speed of power along the conductor. It is measured in amperes, usually shortened to amps with the symbol of I. What is resistance? Opposition to movement of electrons. Makes it possible to generate heat, control current flow, and supply correct voltages to devices is called resistance and measured in ohms, and the symbol is R. Remember, Ohm's law states that V is equal to IR, where V is voltage, I is the current, and R is the resistance. In most simpler way, what is the relationship between voltage, current, and resistance? You can understand simply that voltage acts like a pump, current acts like flow of water, and the resistance acts like a pipe or tube. Now we'll discuss what are the main electrical hazards on a construction site. Overhead power lines, buried underground electrical services, cords that are damaged in any way, wet weather conditions, improper grounding, exposed electrical parts, inadequate wiring, damaged insulation, overloaded circuits, damaged tools and equipment, non-existent or non-functional GFCIs or other safety devices or other electrical safety devices. These are the main electrical hazards on a construction site. What is insulator and what is conductor? Some substances, such as metals, offer very little resistance to the flow of electric current and are called conductors. Other substances, such as bakelite, porcelain, pottery, and dry wood, after such a high resistance that they can be used to prevent the flow of electric current and are called insulators. Dry wood has a high resistance, but when saturated with water, its resistance drops to the point where it will readily conduct electricity. The same thing is true for human skin. When it is dry, skin has a fairly high resistance to electric current, but when it's moist, there is a radical drop in resistance. Pure water is a poor conductor, but small amount of impurities such as salt or acid, both of which are contained in perspiration, make it a ready conductor. When water is present either in the environment or on the skin, anyone working with electricity should exercise even more caution than they normally would. Skin resistance is quite high, although it may vary from less than 1,000 ohms for wet skin to over 500,000 ohms for dry skin. So this is the difference. 1,000 ohms once the skin is wet, and over 500,000 ohms once the skin is dry. Never work on live electrical circuits when your skin is wet. What are the main hazards of electricity? Shock, blast, burn, ventricular fibrillation. Let us discuss one by one. There are four main types of electrical injuries: direct, electrical shock, burn, arc, fires. Indirect, falls. When an electric shock enters the body, it may produce different type of injuries. Electrocution results in internal injury or body parts or the entire body, often resulting in death. After receiving a jolt of electricity, all or part of the body may be temporarily paralyzed, and this may cause loss of grip or stability. A person may also involuntarily move as a result of receiving an electric shock, resulting in a fall. Internal or external burns may result from contact with electricity. Have a look on electrical injuries, how severe and how deep the injuries are. This is the electrical burn. Let us see how electrical shock affects the human body. If there is current flow of 0.5 milliamp to 2 milliamps, the effect is threshold of perception. A person will feel sensation tingling. If the current is in between 2 milliamps to 10 milliamps, there is painful sensation. If the current ratio is 10 milliamps to 25 milliamps, inability to let go, the person will not be able to move. If the current ratio is 25 to 80 milliamps, breathing labored, danger of asphyxiation, loss of consciousness from heart or respiratory failure. And if the ratio of current is between 100 to 200 milliamps, ventricular fibrillation, it will cause death. Now, what is milliamps? Thousandth part of 1 ampere. 1 ampere equals to 1000 milliamperes. Shock severity depends on the path of current through the body, amount of current flowing through the body, a resistance of the body. The body was dry, the skin was dry or wet at the time of shock, and the duration of shock while the current was passing through the body. Low voltage doesn't mean low hazard. It depends on various conditions. As discussed, burns. Most common shock-related injury occurs when you touch electrical wiring or equipment that is improperly used or maintained. Electrical burns typically occur on hands and it hits the tissues along the length of the current flow. This can result in deep burns that often require major surgery or permanent disability. People can receive thermal burns if they are too near the hot surfaces or they are near the electrical explosion. What are the reasons of fires? Due to electricity, overloading of the circuit, overheating of a conductor, ignition of flammable vapors, ignition of combustible material, breakdown of insulation. All these factors may lead to electrical fire. Have a look. Exposed electrical parts. If the covers of the distribution boxes or the junction boxes are removed, there is always the chance of electrical shock with the exposed wires, with the exposed connections. The power connections or the joints are not professionally made. Negligence towards safe work procedure, and it is dangerous. It may lead to electrical shock. What is the strategy to prevent electrical hazards? This may include insulation, guarding, grounding, safe work practices, and personal protective equipment. What are the safety devices that can be helpful to avoid electrical incidents? Fuses, reduced voltage system, isolation, residual current devices, double insulation, formal visual inspections of the equipment, maintenance strategies, implementing permit-to-work system, and deploying competent supervision. All these initiatives can minimize the chances of electrical incidents. This is a best practice. Covers and guards and barriers are in place. No wires are exposed. No chance of electric shock. Grounding. Grounding creates low resistance path from a tool to the earth to disperse unwanted current. When a short or lightning occurs, energy flows to the ground, protecting you from electric shock, injury, and death. Use of GFCI. GFCI stands for Ground Fault Circuit Interrupter, or ELCB, Earth Leakage Circuit Breaker. Both protects you from shock. If ground fault detected, GFCI shuts off electricity in 1/40th of a second, very quickly, very promptly. Use GFCIs on all 120-volt single phase 15 and 20 amperes receptacles, or have an assured equipment grounding conductor program. Temporary lights protect from contact and damage, and don't suspend by cords unless designed to do so. This is the safety of temporary lights. Hand power tools must be double insulated, inspected and color coded, right tool for the right job. Misuse of tools, substandard tools, tools without inspection might lead to an electrical incident. Follow lockout, tagout, LOTO. Any project has specific requirements for LOTO. Always comply with the requirements. Lockout, tagout qualified employees can work under the protection. LOTO accomplishes a zero energy state and there is no electrical hazard. You are required to comply with project LOTO requirements. Failure to comply can result in an injury or death. Don't operate once lockout, tagout is in place. Every lock must have tag attached to it with complete details. Your craft lock and craft identity tag is what protects you from systems being re-energized while you are working on them. Unauthorized removal of locks tags is illegal. If you don't install them, you are not protected. You are watching Safety First. Let us see what is circuit breaker tripping. If you are allowed to reset circuit breakers or other electrical switches, position yourself in the safest location possible. Never stand directly in front of or reach across the device. Every project has specific requirements for who is allowed to operate breakers and disconnects. Make sure you know the requirement before performing these actions. If you are not aware and if you are not competent to do so, don't operate. Moisture provides a conductive path that could result in death. And never work with wet tools or clothing. Humidity control system must be operational. Prior to start electrical work, don't forget to remove your jewelry. Extension cords shall be protected from physical damage at all times. Be inspected and color coded. Be routed so trip, pinch, abrasions, snagging, etc. can't occur. Not be used as a substitute for permanent wiring. Be suitable for the environment. Have a look. Electrical distribution board is badly damaged and still in use. So this may lead to electrocution. While working adjacent to electrical services, overhead lines, follow the safe distance from overhead power lines. Ladders in electrical buildings. Ladders used around electrical hazards must have non-conductive side rails. Ladders with non-conductive side rails that are contaminated with paint, greases, or other coatings may no longer be non-conductive. Check them out. Stay away from exposed, energized equipment. Always look up before you lift or climb up. What is the safety inside the electrical building? Training, lockout, tagout, and permit to work system. Log in and out. Proper insulated tools. Don't open any breaker or touch any live panel. Don't leave panels open during breaks. What is the safety in battery rooms? Eye wash, safety showers, spill kits, non-sparking, non-conductive tools, availability of proper ventilation, no net flame, use of proper PPE, personal protective equipment. Remember, prior to start excavation adjacent to underground electrical utilities. Excavation permit required for all excavation activities on site and follow the safe work procedure. Updated drawings for underground facilities shall be available. No objection certificate is required from the service provider. All the underground utilities shall be identified by using scanners or cable detectors and marked prior to start the excavation. Make trial holes or trial pits manually with the insulated tools instead of picks, forks, or other sharp edge tools. Protect underground utilities once those are exposed. Never use power tools or machinery because it may damage by cutting or crushing the underground utilities. In the case of electrical shock, don't touch the victim. Move the victim with the non-conductive material, wood, rubber, etc. Immediately disconnect the main supply. Call emergency services. Safety for tools and equipment. Safety for tools and equipment. Test tools, instruments, and equipment as per the manufacturer instructions. Use adequately insulated tools and correctly rated test instruments. Not to work on energized circuit as much as possible. Never use aluminum or steel ladder in the close proximity of electrical lines. Personal protective equipment. Personal protective equipment, use of a suitably arc-rated full-face shield may be appropriate when working where there is potential for high current and arcing. Use insulated gloves to the highest potential voltage expected for the work being undertaken. Leather work gloves may be considered for de-energized electrical work. Use only non-conductive boots. Need to be able to withstand 18,000 volts for at least a minute without transferring the shock to your body. They might be fired due to electricity, short circuiting. Disconnect the main supply if safe to do so. Call emergency services, fire brigade. Only trained employees can use fire extinguisher. For electrical installations, use CO2 fire extinguisher. Remember the word pass. P for pull the pin. A, aim low at the base of flames. S, squeeze the handle. And S, sweep side to side. This is the way how you can extinguish the fire. Obey all signs and barriers. Signs, symbols, tags, and barricades are used to warn personnel to potential electrical hazards. Look at the signs, symbols, tags, and barricades and follow the instructions. You're watching Safety First, and safety first is safety always. Remember, don't monkey with electrical fittings. Results of a mistake with electrical energy occur at the speed of light. There is no time to react after the error is made. You must think ahead, pay attention. Risk assessment, activity hazard analysis, method statement, lockout, tagout procedure, and permit to work requirements are not optional. Pay attention and obey all the rules, not just the ones that are convenient for you. They provide the edge. You need to be safe with electrical energy. Be careful with power, or this might be your last hour. Electrical safety is no joke. Correct the hazard or go up in smoke. Training session is over now. If you have any question, please ask in the comment section down below. Thanks for watching. And don't forget to like and share. Hope to see you soon with the new HSC tutorial. Till then, good luck and Allah Hafiz.